for our numerical model, we looked at a group of basketball players and we picked out our worst performer and the best performer. So this graph shows the comparison of the sprint times. So the yellow bar is the worst performer, the darker blue is the group average, the light blue is the NBA athlete, and the red is the better player. So we can see that the taller the bars, the slower the sprinter. So we can see that our performer completed the 20-metre sprint in 4 seconds compared to the better player who completed it in 2 minutes 30 seconds. This tells us that there is a significant difference between the two results. This could be due to power of the performer, this can also be due to the force that they produce, and we can also see from the group average that the worst performer, my performer, is not too far behind the group average. The group average is roughly 3 seconds 20. So we can see that they are around 80 milliseconds behind, which isn't too bad, but it's slightly slower than the group average, so they could try and improve their sprint results to make sure that they're then in line with the group average. The NBA player has an average speed of about 2 seconds and about 40 seconds. So fast, but not as fast as my better player. This difference in the result between the elite athlete and the better player is probably wrong, which means that we may have had perceptive error or parallax error in our recording of our results. This may be due to the fact that we didn't have the right equipment compared to the NBA athletes who had time gates. So this shows us that our method was probably flawed. This graph also shows us results from our numerical module. This shows us our vertical jump results using the jump app. However, they're NBA athletes. Vertical jump results are probably through a force plate. As we can see, our performer has a much lower vertical jump than the NBA athlete and the better player. We can see that the better player is still also a lot lower than the NBA elite athlete. This may be due to the fact that they are not an elite athlete, and it also may be because of their age. These players are around 17 to 18, whereas NBA athletes tend to be older than that. We can also see that my performer's vertical jump results are quite a fair bit lower than the group average. This can suggest to us that they may be lacking in force production and power. They can work on this through they can work on this through plyometric training and other ways of training, but this shows us that they need to improve to be up with the group average. This shows that force and power production is one of their weaker parts of the exercise. Lastly, we measured our performers' power by using their weight and other factors. We can see that there is a massive difference between the power of the NBA athlete and my performer. The NBA athletes' peak power was 8,362 compared to my performer, whose power was only 2,754. There is a big difference of 5,608 between the two scores, when the better performer score was 5,622. So there's the difference between the two athletes is roughly the same as what the better performer managed to produce. This suggests that my performer's power production was a lot lower than the NBA athletes and also the better performer. You can see that there's also quite a large difference between the better performer and my performer, meaning that the better performer is working at a higher level than my performer, and this also means that my performer may need to work on power production as well. These results tables show us the difference between the 20-meter split time results. So the top graph show us the better performer and the bottom graph show my performer. So straight away we can see that for the better performer, the distance time graph is almost a constant flat line, whereas we can see that for the worst performer it's not as straight. So this tells us that the better performer was working at roughly the same speed throughout the whole thing, whereas it tells us for the worst performer that they started at a slower speed, sped up, and then slowed down again and then sped up again. This could be due to their fitness, or it could be due to their muscle fatigue, it could be due to inefficient anaerobic respiration, it could be due to many different factors, but we can see that for the better performer it's a more constant speed, whereas for the worst performer it's not as constant. For the velocity time graph we can see roughly the same thing. We can also see that the better performer has a more steady line, and we can see that as the time increases, it took the performer 2.5 seconds to complete the run, and we can see that the velocity increases to 10, which is slower than which is a lower velocity than the worst performer. However, they do it in a quicker speed. But we can also see that for the worst performer, their velocity starts really low, and it takes them 2 seconds until they have a spike and their velocity increases to around 9.5, and then it decreases, which can also be shown in the previous graphs, because we can see that the line becomes less steep. The steepness of this line shows a really rapid increase, and then the decrease is fairly gradual, and then a really rapid increase in velocity at the end. And lastly, for the acceleration time graphs, we can see the better performer on the top and the my performer on the bottom. We can see that in the 2.5 seconds, the better performer sped up really well, accelerated quite fast, a high acceleration, but then does decrease. However, we can see that my performer accelerates really slow, a very small acceleration, and then increases in acceleration, and then actually decreases their acceleration, so they decelerate. However, they do then re-accelerate quite high at the end. This shows us that the better performer, although they accelerated quite fast at the start, they did lose their momentum for the acceleration. However, my performer shows that they did not have a good acceleration at the start, but then their acceleration fluctuates because they were not able to maintain their momentum. Lastly, we have the advantages and disadvantages of the numerical model. This model is really good for elite athletes as it helps to pick out really small improvements that are key, so it can focus on angles and particular forces, whereas for a younger athlete it may not need that much improvement. It also means that these elite performers can refine their training to focus on specific adjustments. This numerical model also uses really advanced equipment and advanced technology, so it means that we could have more advanced kinetics and kinematics and more advanced and more reliable results. Another advantage of the numerical model is more simple tests can use cheaper software. So Dartfish, for example, you can use Dartfish instead of the 2D. And it can show you the same thing, but it can be in a cheaper way. And then lastly, for advantages, that the model can help the performer strive and set a goal for their improvements, because they can see, oh, this angle is meant to be 45 degrees, but mine's 54. I can strive to get mine to a 45-degree angle, and then it gives them something to look forward to and a goal. And then lastly are the disadvantages. So it's quite difficult to access a lot of the equipment if you are not an elite athlete, and if you don't have the money for it, it can be quite expensive to get all the equipment. So if you do decide you want to get the correct equipment, renting it out or buying the equipment can be really expensive. So one of those force plates that we use, well, we didn't use, that you could use for the measuring of force can be roughly £2,000, which can be very expensive. Another disadvantage of the numerical model is that you must have quite an advanced knowledge and understanding of the thing that you are measuring, and it may not make sense to a younger child or to a less experienced performer, so it may be less suitable to use the numerical model for them. And then lastly, you need to understand like a range of components and not just force and speed, so you need to understand that it uses acceleration, deceleration, momentum, impulse, and lots of other factors that aren't just force and speed. So if you don't understand the knowledge and the understanding of these other factors and components, then you may not be able to produce the correct understanding and results from your model.